This is the 20th of April, which is 420 in the US form. It's a code term in the cannabis culture that refers to the consumption of cannabis, especially smoking cannabis around the time 4:20 p.m. So that was 1.5 hours ago, and thankfully the organizers were kind enough to give us a break between 4 and 5, so I don't know how many of you used the opportunity to participate in 420. I abstain, unfortunately, since I'm speaking, but it's a good day today. This should be good. So, Datomic. So if you feel like you're tripping, the logo is kind of weird looking, so that might not mean that you're high just because the logo looks weird. So Datomic is a database, and it's a very different database. The title of this talk is it's called Datomic, the functional database. And in the previous talk, we just learned that that's where functional breaks down, right? In the database, you have all this nice pure Scala code, and then you put a database into it, and then suddenly nothing is functional anymore because you have this huge blob of mutable state. But first of all, I have to remind you to try not to laugh for 2 reasons. Because Datomic is kind of strange, and I'm going to say some things about Datomic that might make you want to laugh. And also, if you laugh a lot, that's like a giveaway because of 420, right? That means you're probably high if you laugh very much. So be careful with the laughing. You laughed. That's all I'm going to say. Okay, so queries runs on the client. Okay, good. Nobody laughed. You followed my orders. Nobody should laugh. It needs to be taken seriously. So this this sort of goes against everything we know about databases, right? There's 3 things. First of all, we're supposed to package our queries into a string or something and ship it off to the database server, and then the database server runs the query, and then we get data back. And we've also learned that, like, let's say you're listing a bunch of projects, then you're not supposed to then do another query for each project to like count the number of to-dos in that project. You're supposed to do all of that in like one query. That's the way it works. And like the worst thing you could possibly do is to like pull all of your data into your application and then query it with your code or something. So let's say I'm certainly guilty of this when I was much more inexperienced than I am now. I had no idea how to use regular expressions with SQL, right? So I just pull all of the data into memory and filter it with a regular expression with my own code. And you're definitely not supposed to do that. However, here I am claiming that Datomic is an awesome database and it runs queries on the client. So what's up with that? Well, there are 2 big things. The first is that when we invented databases in the 70s, our computers weren't like today, right? They were super expensive. They weren't so fast. They didn't have that much memory. And this continued for like many decades after databases were invented. So it has been this way for a long time that you had like your database server, like that was your huge big server where you put all your money in because it needed the fastest CPU and it needed like maybe a gigabyte of RAM. And that's like where all the heavy lifting happens. So you need this big server. And that's not really true today, right? Because servers aren't expensive anymore. I mean, they are, but it's much more different than it was in the 70s, where your database server cost probably 100 times more than your application server. Right now, you just have to go into your cloud and pull a slider, and then you have a huge application server as well. So that has definitely changed when it comes to like the architecture of the database. There's no longer like a fundamental reason for having a huge, expensive database server in one place. And secondly, this was something it's usually unfamiliar to application developers. It definitely was to me when I got into Datomic, which is that someone has to have the working set in memory, right? So when you use a database server like Postgres or MySQL or any of the database servers that we have today, it has the working set in memory. It has to have, right? The data that you run your queries on, it has to be memory. If it has to go on the disk all the time to read data, it will be super slow. So the working set is in memory on your database server. So having that in mind, it has to be in memory somewhere, and servers are no longer expensive, why do we have to run the queries on the database server? Right, so what Datomic does, it's not what we did when we just learned to program, right? To pull all of the data into memory and just filter it with code. It basically takes the query engine that usually lives on the server and puts it into the client. So essentially the same thing happens, like you have a good query engine and you have index data that's able to query your data efficiently. It's not just like stupid for loops as it would be if you did it yourself, right? But it exists in the client instead. And this has a bunch of benefits. One of them is that something I unfortunately won't be able to go into detail, and maybe you won't trust me when I say this, but 2 different clients running queries in Datomic doesn't require any coordination. So it's very easy to scale queries when you use Datomic. So let's say that you have this super expensive query that takes like a couple of hours to finish, that you want to run like once a day or something to generate a report. You can just spawn a machine to do that with lots of RAM, have that run the query, and it will not affect the other queries, your application service, in any way, shape, or form, because of the way Datomic completely separates or doesn't require coordination between clients. Let's go on. This is number 1, queries run on the client. So try not to laugh. Writes are single-threaded. Good, no one is laughing. You're still taking me kind of seriously, or at least being polite. That's good. So we now see that queries run on the client. Maybe that's not such a bad idea, but this cannot possibly in any universe be a good idea, right? That you have a single thread doing writes. This goes against basically everything we learned. I mean, it's kind of the opposite of what I just said, right? I just made the point that machines are now cheap. So we have all these multi-core machines. So why should we do single-threaded writes? So first of all, it's like a self-evident point. The data model in Datomic is very easy to reason about because writes are single-threaded. I like to call this isolation level 9000 because there's no such thing in Datomic as having a thread doing something or a transaction doing something, having another transaction see leaks of that other, because transactions are applied one after the other in a single thread. But I mean, that's all good, but there's a reason for why we have multi-threaded databases, right? Because of performance. So it's very convenient to have a single thread, but how can this possibly be fast? Well, it turns out that this is research done by Michael Stonebraker. Anyone heard of Michael Stonebraker? He's the lead architect behind Postgres. So he's like one of the titans in the database world. And he found that in typical OLTP workloads, so that's database speak for online transaction processing, which is basically everything I do with a database, like a bunch of transactions, a bunch of read and writes going on at the same time, as opposed to like data warehousing, which isn't OLTP. So in OLTP workloads, it turns out that 75% of the time is spent doing coordination, and only 25% of the time is spent doing like actual reads and writes. And this is like in big databases like Postgres. So that means that 75% of the time your database or CPU power your database server uses is done only to make sure that your actual reads and writes don't conflict with each other and do something dangerous and overwrite each other, right? So there's this huge overhead to multi-threading that we don't typically think of. But I mean, obviously there's some coordination, right? But it was certainly a surprise to me that it was this much, 75%. So when Datomic does writes in a single thread, you could say that 1 core of Datomic is as good as 4 cores of Postgres. So my point here is that a single thread that does writes can actually scale more than is intuitive to most developers, at least was intuitive to me. I was really surprised when I found this out. So obviously you can have like 50 cores of Postgres, right? And then it'll beat Datomic in terms of write performance. So it's not, Datomic isn't the database for extremely heavy write loads, but you have the enormous benefit of a very easy to reason about transaction or like a timeline in your database. There's no things that can go wrong because it happens simultaneously, and it performs better than you probably think it does. So, Datomic runs queries on the client, and its writes are single-threaded. So, some of you are maybe thinking about event sourcing at this point, and that means you've been paying attention. So, event sourcing kind of looks a little bit like Datomic, in that event sourcing is like it's a model for working with data, where you have this log of events that happens, and similar to Datomic, it's a single thread, right? It's just one event after the other, after the other, after the other. There's no like concurrency there. It's just one consistent timeline of one event after the other, just like with Datomic. So in event sourcing, these events are just data, arbitrary data. And then you have this left fold function, which to Scala people should sound familiar, which basically means that you have a function, it takes the first event and returns a state, and then that function is called again with the next event, and the previous state is passed in, and then you thread through the events like that until you end up with this view. So let's say that this first event over here was create user, then was delete user, so then you're left with like nothing after that, then create another user, so you just fold through from left to right, and you end up with a state. So that's event sourcing. So since event sourcing is in many ways a more familiar concept to most people than Datomic, I thought I'd explain more details about Datomic in terms of event sourcing. So how is Datomic different to event sourcing? And the answer is in very many and very useful ways. So I could probably talk for like 2 hours about this slide alone, right? Because this is where it starts to become interesting. This is where like Datomic separates itself from other systems. So similar to, so here's event sourcing, here's Datomic. So we have this same red line, right, of all these events, except that they aren't called events, they're called facts. And that's one of the differences with Datomic. So it's not just arbitrary data, it's a very specific structure called a fact. It's similar to RDF, if you've ever worked with that. And you also see these vertical lines. These are transaction boundaries. So you have like a set of facts that are part of one transaction, and Datomic is completely ACID, right? So it will apply all or none of those facts to the database. So you ship these facts to Datomic, and then you send them to what Datomic calls the transactor, which it's both helpful and unhelpful. That is called a transactor, because we've seen that queries doesn't happen on like the Datomic database server, right? Datomic queries happens on the client. So the transactor really is like the database server for Datomic, but it only does writes, because reads or queries are done on the clients, not on the server. So that's why they call it a transactor in Datomic. So you ship these facts to your transactor in form of transaction, which is a set of facts. And the huge benefit here is that the only sort of limitation you have is that you have to express your data in terms of these facts, and then Datomic does everything else for you, as opposed to event sourcing. So one of the big problems with event sourcing is, what if you want to add a new view? So what do you have to do then? Well, then you have to go through all your data from beginning of time, right? And generate a view, because you can't just start in the middle, right? Because what if a user was created before that? Then you wouldn't know that, right? So you have to go through from beginning of time. This also, if you have like a bug in your left folder code, right? You have to run through everything again. So with Datomic, you don't have that problem, because that problem is solved generically. Datomic does this for you. It just takes these facts and it builds up a view of the database with a generic transactor that just takes facts and these generic indexes that you can query. So instead of having to decide upfront what kind of views you want for your database, you just put your data into there and it becomes a generic engine for querying your database. Which makes you much more agile, for one. Like, you don't have to make decisions up front. What do you want your views to be? What you want your access patterns to be? You just put your data in there, and it becomes accessible and queryable. Also, you're much less prone to bugs, right? Because usually there can obviously be bugs in Datomic, but Datomic is generic code that you didn't write. It's a service that someone else wrote and battle-proofed, as opposed to in event sourcing, you write these leftful functions yourself. So there's a lot of interesting aspects that arise from this because of the way Datomic works. And there's just one thing that I want to mention, and this is what makes Datomic a functional database. So when you're going to query Datomic, you have a connection, and that's where you send facts to be written. But you don't query the connection, at least not directly. So what you do is that you take your connection and you ask for a DB. And a DB, short for database, is represented as one of these lines here. That's basically what a DB is. So when you ask Datomic for a DB, you get a view of your database, your entire database. That's completely immutable. And you can just hold on to that forever, for as long as you want, right? That's what immutable means. So in other words, your querying code becomes completely functional. So let's say that I ask Datomic for a database, I have a connection, and then I get the point, this point here is the value I get. But let's say that this is the point where I ask Datomic for a value. So what happens is that no matter how much data is added to my database, I can infinitely hold on to this value of the database. And here's the important part. This happens without any coordination, right? There's no locking that has to take place, because what you can also do is that you can go back as many steps as you want. So all of these points have an ID, transactions have an ID, or you can also give it a timestamp and it will find a transaction matching that ID, and you get a view of your database as of that point in time. Because of the way Datomic is sort of like event sourcing, but not really event sourcing. So you have your entire history is there in Datomic. And you can step back like that. So a lot of interesting aspects arise from that. I'm going to mention two. So one thing that happens is that your system in production starts sending errors to people on pager duty in the middle of the night, but maybe nobody checks those errors because they're not so important. So you go to work in the morning, and the problem is gone because the user managed to tweak something, and the database is now in a different state. So what can you do in Datomic? Well, you just ask Datomic, what did my database look like 3 in the morning tonight? And then you can do your decisions based on that. Also, the other really cool aspect there is that all of your querying code takes a DB with this immutable representation of your database. So let's say that you want to have, you have some business logic that runs a query, and you want to run that query for like the database as of a week ago. You just do that, right? You just ask for a database as of a week ago. You don't have to, like you typically do in a SQL database where you have to model time yourself. You typically have one query for getting the current state and then another query for going back in time, right? So it's super convenient. So that's all I was able to do, get through in 20 minutes. I wrote a blog post today. No, not a coincidence. It's on my blog, augustal.com, Datomic. Look at all the things I'm not doing. And there's the FProg user group meeting on Sunday, where I'll do a 45-minute, more like hands-on Datomic with like examples of how you actually interact with Datomic. And there's a Scala binding. Since this is a Scala conference, I thought I'd just mention that. Okay, thank you.